Hey, this is where I left off last time. My pen didn't work, so I had to stop the video segment 1 and do the rest of it here. Okay, so I believe it was right there. We stopped right there. So we have y equal to 1/2 cosine of 4x. We may have done this, but we'll repeat it again. So there is the amplitude, the positive number that's multiplied by cosine, and that's equal to 1/2. And there is the value of k, which is 4. Now, this tells you that the period of the period of the function of this cosine function is equal to 2 pi over k, which is 4, or pi over 2. Okay, in other words, that means that if you go to a cosine function, and if you plot it y equal to cosine of 4x, notice that I'm leaving out the 1/2. Eventually, I'm going to come back and put the 1/2 there. The period is pi over 2. In other words, you have to fit the cosine between 0 and pi over 2. So this starts at 1, goes down to -1, goes back to 0, and up to 1. Okay, so this is cosine of 4x, but we are interested in cosine of 1/2 of 4x. That means all the heights are actually shrunk by a factor of 2, or all the heights are multiplied by 1/2. So it goes like this, because remember this height is 1, so it has to go to 1/2. This was -1, and it's going to go to -1/2. Of course, it is periodic, so this thing repeats itself. Same pattern with a period of pi over 2. So the actual curve, the answer to this problem is that blue one, not the red one. The red one helps us to put the blue one together. All right, let me do the next one, number 22. Okay, and I'm going to get rid of the stuff that I don't want here so that this does not get too cluttered. Okay, so let's get rid of all this. Oh yeah, maybe there's an easier way of doing this thing. Okay, yeah, this probably is better. For erasing purposes, I use my mouse. Not my mouth, my mouse. Okay, so here, number 22. Let me write it down first. One more time. So we have y equal to 5 cosine of 1/4 of an x. That means the amplitude is this positive number 5. Obviously, because it's bigger than 1, it's going to be stretching of the appropriate curve. So k is 1/4. That means the period is 2 pi over k, which is 2 pi over 1/4, and that is 8 pi. Okay, so let me go ahead and first draw y equal to cosine of 4x, and then once I get that, then I stretch everything in the vertical direction by a factor of 5. Okay, so what does that mean? The period is 8 pi, so there is 8 pi. Between 0 and 8 pi is where I have to concentrate. Alright, so this height for cosine is between 1 and -1. I have to fit the cosine in between these. So this is going to be halfway point, which is 4 pi, and the curve is going to go, the cosine is going to go to 0 here and 0 there, and a height of -1 here, +1 there. So squeeze right. It's supposed to be nicer than that. Okay, good. So there is cosine of 4x, okay? But what we want is 5 cosine of, oh, I'm sorry, this is not 4x. That's not what I meant. I will want quarter of x, not 4x, okay? So what we want is actually 5 times this. So when we go, if we stretch everything by a factor of 5. So this is 1, it's going to go to a 5. Obviously, this is 0, it's going to stay there. So the curve is going to go down. I'm going to clean this up in a minute. And then this was minus 1, so it's going to go to minus 5. Like this. It's going to go back to 0, and it's going to go to 5. So this is the height 5, this is the height minus 5, and then of course it repeats itself with the same period. So if I wanted to do a better job drawing this thing, I would do the following. There we are. There is your 8 pi, the period. Okay, so the curve would go like this. This is cosine. Minus 5 and up and 0, and then it repeats itself. If you want to mark some of these points, so for example, this is 8 pi, this is 4 pi, this is the halfway point, this is 2 pi, okay, and this is the 6 pi. Alright, so the ugly quick sketch of 5 cosine of 1 over 4x is right there. Okay, let's do the next one. How about doing this? 4 sine of minus 2x. Okay. Alright, let me first of all clean up this stuff. Let's clean this up. Just leave the stuff that we want. I just realized that maybe a faster way of getting rid of all of these is to I guess not. I don't see a faster way of doing it. I was gonna trap it with a rectangle and then delete it, but I'm really not very good at using this tablet. Okay, very good. Okay. All right. Now, first of all, notice that we have what? We have y equal to 4 sine of minus 2x. Okay? One way to do this is to realize that sine is an odd function. We can put this thing minus in the front. So this is equal to minus 4 sine of 2x. Okay? That's the first step. Now, in order to draw this, first I will draw this guy. In other words, my first task is plotting sine of 2x. Once I do this, then I'm going to multiply it by 4 to get the 4 sine of 2x, and then I multiply it by minus, in other words, mirror with respect to x-axis to get the final curve. Now, when there is a number here, we know from the book, and let me see if I can bring that right here. I'm going to this particular cutout of the book. Notice that there is a K here, right? There is a K here. Okay. So, well, first of all, this tells you that K is 2. The period is equal to 2 pi over K, which is 2 pi over 2, which is pi. Okay. So just like the previous problems that we have done, we go between 0 and pi, and we have to squeeze this sine curve with amplitude of 1, because this is what we're doing. The amplitude is 1. It goes between between 1 and minus 1. Okay? Now, of course, this thing repeats itself. You do realize that we're only drawing the portion that is critical to us, because then it's going to be a repetition of this pattern. Now, we have a 4 here. So all the heights are, I'm going to use a different color. All the heights are increased or multiplied by 4. So obviously this height is 0. It doesn't go anywhere. But this height is 1. So it goes way up there. Way up there. And then it comes back to 0. And this is minus 1 over here. So it goes to minus 4. And then it goes to 0. So this is supposed to be minus 4. This is supposed to be 4. Now, please excuse my drawing here. But then there's a minus sign in front of that. You see this? There's a minus sign in front of this thing. Right there. So, all the positive values are turned into negative, and all the negative values are turned into positive. So if I use the green one, the mirror of that is like this. The green one is our final solution, and of course it's going to repeat. And I'm going to clean it up in a minute. All the stuff that I don't want, I'm going to clean it up down here. So let me first get rid of this junk. I'm going to get rid of this. Okay. And I'm going to redraw that green one on a clean axis without the intermediate curves being present. Okay. So let's do that. Green one. The period was pi. So here is pi. Okay, so this is going to go to a height of 4, goes down. Oops. let me do a better job here. This is not the way I wanted to do it. So let me get rid of this. Let me put the pi here so that I have more room. So here's pi. Okay, so I have to fit that green curve over here, which goes from below to 4 above the axis. So this is 4, this is minus 4, there's your pi, see this? There's your pi right there, alright, and then it repeats itself. Like that. So obviously if I make one more cycle of this, this is going to be 2 pi, this is going to be pi over 2, this is going to be 3 pi over 2, etc. So this is one complete cycle, you can see that, one period, and then it repeats itself indefinitely until eternity. Okay, let's do this one now. Right there. This one. Y equal to minus 3 sine of pi x. And let's get rid of all the stuff that we don't want here. Oh, this is going to go, the red one is going to go. There is no screeching noise here when I do it with the mouse. But when I use my pen, there's a screeching noise. Okay, good. So, let me write it here. Right. y equal to minus 3 sine of pi x. Remember, the amplitude here is 3. It's this positive number, ignoring the minus sign. And the value of k is equal to pi. So the period is equal to 2 pi over k, which is 2 pi over pi, which is 2. The period is 2. So the period is 0 to 2. Now, if I ignore the minus 3, so if I just concentrate it on sine of pi x, which is not my final curve, so we have to take one sine curve and stick it or fit it in that period 0 to 2. So this is going to be 1. The curve starts here, goes up, goes to 0, and goes to 1 and 0, minus 1 and 0. So this is one cycle of sine of pi x. Now I have minus 3. The first thing I'm going to do, I'm going to increase everything by a factor of 3, stretch everything by a factor of 3. So the red one is 3 sine of pi x. But I also have a minus sign here. That means that everything is going to get reflected or mirrored with respect to x-axis. So here's the blue one. So it's going to be exactly like that red one above it, except that it's flipped, mirrored. Okay, so the final answer for our problem, minus 3 sine of pi x, is this blue curve. However, I'm going to clean it up. I'm not going to leave it like this. So let's see now. Let's erase all the stuff that we don't want. And I'm going to draw that right here on the left. And let's erase all of these. Actually, these are all going to go, right? It's this thing. So let me put some axis here. So this blue one. So here is 2. This goes, here's 1. So we have like that, like this, where this height is 3 and this is minus 3, and of course the curve is going to repeat itself. Okay, so this is 3 and this is 4, etc. 2, 3, 4. Yep. And this is, by the way, minus 1 and minus 2. Alright, now let's do this one. Let's do a cleanup here. So this is all going to go. We just want that one. Okay, so let's consider a cosine of 4x. So if I had cosine of 4x, k is 4. So the period, 4 pi, cosine of 4 pi x, that's what I meant. Cosine of 4 pi x, that's what we got. So period is equal to 2 pi over k, which is 2 pi over 4 pi, which is 1/2. So the period is 1/2. Okay, so if I was to plot this curve, it would look like this. The period is 1/2, so this is 1/2, this is 1/4. So I have to take one of these cosines and stick it in there. Let me see now. Just a second. Gotta be careful here. Okay, there. So you gotta take one cosine and stick it in there. So remember, it has to start at 1. This is the middle point. It has to go to minus 1, and it has to go back to 1. So let me do it like this. So this is going to be 1/2. This middle one, not 1/2, 1/8. This middle one was 1/4, and this, of course, is going to be 3/8. This point is going to be 3/8. Okay, so this is cosine of 4 pi x. Now I have to add -2 to it, so shift everything down by -2. So this was +1, this was -1. Shift everything down by -2. So let me try it here. This point that's up here, see this point? Well, if you shift it down by -2, it's going to end up right there. If you take, for example, the point at that location, which is 0, and you shift it by -2, it's going to go down here. Down here. That guy is at -1, it's going to go to -3. So it's going to look something like this. Roughly something like that. And of course, it's going to repeat itself. So this is -1, down here is -3, etc. So this red curve that you see, okay, which is basically hovering around -2. See that? This is -2 location. Hovering around -2 is going to be the answer to that problem. I'm going to stop the video segment here and we move on to the other problems. So let's stop this.